Here we have the function arc sine or sine inverse of 4x divided by 8x, and we want to find the derivative. And so this is a quotient, so we have to use the quotient rule for derivative. And so it'd be the denominator 8x, and then times the derivative of sine inverse of 4x, or arc sine of 4x, and then minus arc sine of 4x, and then times the derivative of the 8x, and then dividing by 8x squared. And that's the quotient rule. The derivative of the 8x, that is 8. And then let's just go ahead and square this. 8x squared is 64 x squared. And then the derivative of arc sine of 4x, and then it'd be the chain rule right here. So once again, if we just have sine inverse of x, then it'd be 1 over the square root of 1 minus x squared. So here we have arc sine inverse of 4x, then in the place of x, we would put 4x. And then the chain rule is we have to multiply it by the derivative of the 4x. And this will be, in the derivative of 4x is just 4. And so here we just get 4. And so in the derivative sine of 4x would be this. And then we can simplify a little bit. So 8x times 4 would be 32x. And then we can place the 8 in front of the sine inverse. We can simplify a little bit more, but then we can just go ahead and leave it like this. Here we have the function of sine of tangent inverse of x, and we want to find the derivative. And recall that the derivative of sine is just cosine of x. And so if we just have sine of x, then the derivative is just cosine of x. But here we have sine of tangent inverse, and therefore in the place of x, we will put tangent inverse of x. And then by the chain rule, we have to multiply by the derivative of the tangent inverse of x. And so now we get this, but the derivative of tangent inverse of x is 1 over 1 plus x squared. So the final answer will be this. Here we have the function 12 times tangent inverse of x, and we like to find the equation of the tangent line at the point 0, 0. And the graph with the function 12 tangent inverse of x is right here, and this is the point 0, 0, and this is the tangent line, and we like to find the equation of this tangent line. And so to get the equation of the tangent line, we have to get the derivative and then evaluate it at 0. So the derivative of tangent inverse is just 1 over 1 plus x squared. So we end up with 12 over 1 plus x squared. And then we need the derivative at 0. This is the slope of tangent line. And then in the place of x we have 0, so this is equal to 12. So equation of tangent line and we use the formula y minus y1 equal to m times x minus x1. And again, x1, y1, that's the line that the tangent line passes through. That's the point that the line passes through. In this case is 0, 0. So we have y minus 0, and then the slope of the tangent line is 12, and then x minus 0. So we end up with y equal to 12x. Here we have the function 2x times sine inverse of x minus 1, and we want to find the equation of the tangent line at the point 1, 0. And this is the equation for the function 2x times sine inverse of x minus 1. And this is the point 1, 0, and this is the tangent line, and we want the equation of this tangent line. And so first we need the derivative to get the slope of the tangent line. This is a product, and therefore we need to use the product rule. So it'll be 2x, and then times the derivative, this right here, and then plus the second factor, and times the derivative of the first factor, 2x. The derivative of the 2x, that is 2. And then we need to find the derivative of the sine inverse of x minus 1. Once again, if we just have sine inverse of x, then the derivative be just 1 over 1, the square root of 1 minus x squared. But here we have the sine inverse of x minus 1, and so in the place of x right here, we would put x minus 1. And then the chain rule says we have to multiply by the derivative of x minus 1. And the derivative of x minus 1 is just 1. And then 1 times 1 would be just 1. And this is the derivative, and then we can go ahead and rewrite it like this. This will be 2x, and then plus, and then this is 2 times sine inverse of x minus 1. And then we need the slope of the tangent line at x equal to 1. So x will be 1. So in the place of x, we put 1. Two times 1 is 2. 1 minus 1 is 0. So we get 1 minus 0, which is 1. The square root of 1 is just 1. 1 minus 1 is 0, and recall that the sine inverse of 0 is just 0. 0 times 2 is 0, so we get 2. And therefore the slope of the tangent line is 2. And so now equation of tangent line so we get y minus y1 equal to slope, and then x minus x1. And again, the x1, y1, that's the point that the tangent line passes through, which is 1, 0. And so we get y minus 0, and then the slope is 2, and then x minus 1. So the equation of the tangent line will be 2 times x minus 1.